Here's another variation problem, problem 72. The time required to assemble computers. Okay, so let's call that T. The time required to assemble computers varies directly as the number of computers. Let's call that C for the number of computers. So it varies directly as the number of computers. Wouldn't that express direct relationship, direct variation between the time it takes to assemble computers and the number of computers that you have to assemble? The time required to assemble computers varies directly as the number of computers assembled and inversely as the number of workers. Let's let W represent the number of workers. So inversely, the W would have to go down into the denominator, wouldn't it? And that makes sense. The more workers you have, wouldn't it seem to take less time to assemble those computers? But the more computers you have, it should take more time. So those relationships make sense. Now it says, so we've accomplished part 1. We've written our generic equation. Now we go to part 2, step 2 of our 4-step process for solving variation problems. If 30 computers, all right, so that's C, can be assembled by 6 workers in 10 hours. Okay? So 30 computers can be assembled by 6 workers in 10 hours. Now I can find my K value. That's multiplication. Can't I cancel when it's multiplication? I just can't cancel when it's addition and subtraction that join those two items. And now we divide both sides by 5, so we get our K values equal to 2. So the specific equation that comes into play here is that T equals 2C over W. We found our K value from the specific example they gave us. Now we can use that equation to answer the question. If that's the case, in that case, the example they gave us our K value of 2, how long would it take 5 workers, okay, 5 workers, our K value is 2, how long would it take 5 workers to assemble 40 computers? So how long? How much time? So what have we got? 5 goes into 48 times. 2 times 8 is 16. So it would take 16 hours for 5 workers to assemble 40 computers. Again, notice the 4-step process. Generic equation based upon the relationships, based upon the variation that's taking place. Take the specific example to find K. Create your specific equation. Use that specific equation to answer the question you were asked.